Welcome to Lesson 7. This one's about simplifying drawArena. drawArena, as you may remember, is really complicated, and I found a simpler way. And often this happens in programming. You'll find a simpler way. Maybe if I'd thought about it a bit more, I wouldn't have made this complex thing here. So let's get rid of a lot of it that we're not going to need. We'll need this loop. We won't need any of this. We will need that. Not this. Bring this over. I want to use shorter variable names for these. You'll see why. So I'll call this L for largest. Watch out if you use L because it looks a lot like a 1. A lot of programmers will not use it for that reason, and that's understandable. So we've got the largest coordinate value, smallest coordinate value. And then here we are going to draw lines. So let's start by drawing the pattern of horizontal lines for the back wall, but we'll do it in the center. Okay, so that should look like, so just this is in the form x1, y1, z1, x2, y2, z2. And we're going to put it in the center. You'll see why later. So the z's are going to be 0. And for horizontal lines, they are all going to have the same x coordinates, which are going to be here the smallest and then here the largest. So going from left to right. And the y is going to vary. So our loop varies this v here. So we'll put a v here. And now when I run the program, I see the horizontal lines right in the center. Okay, let's do the vertical lines and then we'll see how to push it to the back wall. Let's duplicate this. And for vertical lines, the z is still going to be at 0, but this time the x is going to vary. So that's the x, and the y is going to be from smallest to largest. Z is still at the center. Okay, there we go. We've got one of our panels, our walls if you like. It's just in the center. And this is where we're going to create it, but then we're going to push it and then rotate it. Let's see what we need to do to get it to the back. You may already know that we want to translate it to the minimum value, the lowest coordinate, the smallest coordinate. And we better have push and pop around this, or we're going to interfere with other things. Okay, it's on the back wall. Great. Now let's do the right wall. Now I'm going to duplicate this code just for purposes of this demonstration, but normally we want to avoid this, and I'm going to delete it later. Okay, so now for this next one, we need to translate and rotate. So we want to translate it over to the right, to the largest x value. Well, let's see what that looks like. Okay, I've brought it over there. This is the one closest to us. And now if I rotate it on y, then it'll kind of turn into position. So let's rotate it on y. By a quarter turn, and we'll define that to be tau over 4. Tau is 2 pi. Some mathematicians prefer using tau to 2 pi. Tau is a letter of the Greek alphabet. All right, we're rotating on y by a quarter turn. And great, that pops into place. Now to do the floor, we need to translate it down and then rotate it on which axis? Let's find out. I'm going to duplicate this, and we need to translate it not on X or Z, but on Y, down to the largest coordinate. And I'll just comment out this rotate. Let's have a look. Now that it's down there, it looks like we could rotate it on X, and that would do it. If we rotated it on Y, that wouldn't do it. So here we need to rotate on X by a quarter turn. Great. So much simpler code. It's duplicated. Now we have to find a way to remove this duplication. So we study these three blocks, and we ask ourselves, what is it that's in common among these three blocks? Well, they all have push and pop. They all have this identical loop. The thing that's different is the translates and rotates. So here's a translate. Here's a translate and rotate Y. Here's a translate and rotate X. So how can we encode that in some kind of data structure? Let's do it like this. We'll make an array. I wonder if I could turn off those. Yeah, let me turn that off for the moment here. I don't want that looking ugly while we're building this. Okay, so here's an array, and there's going to be one element in this array for each of those three walls. And each of these elements is going to be an array. And what's it going to contain? Well, it's going to contain the translation values. So they're going to be in an array. And then we're going to have how much to rotate on X and how much to rotate on Y. So let's just go and fill in these numbers. So the first one, here are the translation numbers. Let's just put them in. And there's no rotation at all for this first one, for the back wall. Okay, so we're done with this. Actually, let's leave it for the minute. So next is L00 and L00, and we rotate on Y by Q. So we don't rotate on X, but we rotate on Y a quarter turn. Finally, 0L0, and we rotate on X by Q. And we don't rotate on Y. Okay, we have the information about the translations and rotations that we do contained in this array. And now we want to iterate over the array, so we'll use for each. And we'll call this transformations. So for each transformation, we're going to do something. And the first thing we want to do is extract the various pieces of it. So we'll say, remember we're operating on one of these lines at a time. So we have an array, and this line 126 here pulls it out into three parts. So pos is going to contain this array. Xrote will contain this number. Yrote will contain this number. That just makes the code that follows easier to read. Now we have our at function. You remember that? That one will do a push, a translate, and then whatever you want, and then a pop. So we'll say at the position. And what are we going to do at that position? Well, we're going to do our rotations and then our loop with calls to line. So let's first rotate on X by Xrote. Then we'll rotate on Y by Yrote. And then we'll copy this from here. Actually, I'm going to just move it up. And now we're done with all these. So we've eliminated this duplicate code problem. And the function now is quite a bit shorter. I can take this out now. That was to eliminate that warning, those underlined squiggly things. Okay, if we've done this right, this should work now. Beautiful. Isn't that simpler than the way it was? Okay, that's it for this one. See you next time.